like 6, but I don't want you to, it's up to you,
Yeah,
totally up to
do
you.
whatever you think.
Okay, because typically the word ones are available on online.
Okay.
That's totally
Okay, yeah, that's fine.
your call on this. Okay, so this one here, a simple random sample of 8 employees of a corporation provide the following information. Determine the point average for the estimate for the average, point estimate for the standard deviation, point estimate for the proportion of all employees who are female. So option 1 here is to do this in Excel or a calculator. What would be best for you? Like, what are you going to have access to on the test? If
I have a calculator.
like a TI-83?
84.
84. Okay, good enough. So let me grab my virtual TI-84, pull it up, show you how to enter this in case you have not seen that before. It'll take a little bit longer for the first one, but then it'll go a lot faster for the subsequent ones. So let me get that loaded up here. All right, so I'll put the instructions as well on the notes here. So you want to go to second list. I'm sorry, no, that's not right. Stat edit. Stat edit is where you go to enter the data. Stat edit.
Okay.
Hit enter. And if you have stuff in list 1 already, you can go up to L1 and hit the clear button to enter it out. In this case, there's nothing there. You want to enter the data points. So most of the mistakes are made entering the data values, meaning you just don't type them in, you miss one. Many possibilities. Very important to get that right when you're entering it and double checking all that stuff. Okay, that looks 22. Okay, let me know when you've got all that done. You've got your calculator.
I lost you on the first part.
Oh, how to get there?
Yeah.
Stat edit, and hit enter. Then you'll see the list.
Okay. 1 second. Okay. I got that now. So then for L1, type in
all the data points. Yeah, 21, 35, all the way up there.
After I do 21, do I hit enter?
Yes, good question. So you hit the number, enter. I think you might even be able to, yeah, I don't think you can hit the down arrow. Calculators aren't like phones. They don't work as well with what we think should work.
Then I just space over to L2.
No, go all the way down through L1. You're seeing my screen, right? Yes. Yeah. Okay, yeah. So they should all be in L1, all the data points.
Okay. Got it.
Okay, so the next thing is to quit. And to quit, you hit second, quit, and you go back to your home screen, which you might think, why did I enter all the data? You enter the data, then you evaluate the data. To do that, you go to stat. This time you go to calc.
Sorry, second quit.
Yeah, second quit is the BL button at the top, quit, which is the mode button.
Okay.
And then you hit stat.
Okay.
Go over to calc. And then you click, you're gonna hit enter on one var stats or one variable stats.
Okay.
So hit enter. Now yours probably has a screen. Mine is not very modern, so I have to actually type in L1, but yours should say already L1 and a paste somewhere.
It doesn't.
You don't have anything that says L1 at some point?
No, it just says 1/var stats.
Okay, so to get L1, it's second, and then L1 is above the 1 key.
Okay.
I know this seems like a lot, but do it a few times, you'll have it down, and it saves you a ton of time.
All right, I got it.
And then you hit enter. So you should get, hopefully our numbers match, 34.25 for the mean.
Yep.
So that's not, I mean, you might think, well, that's not a big deal. I could have done where the standard deviations where you're saving time, this 12.4183. Okay, so
That's what we want.
that's what you want for the first two. Then we'll talk about the third box. So I'm going to snip this into the other screen, but you want to enter those in, do it now, do it later, up to you. But I'm going to go back to the other screen. All right, so this is the answer for A. This S is the answer for B, 12.4183. C is a little bit more involved. Let me know when you're ready to do part C.
Do I type in 12.4183?
For B, yes.
All right, I'm ready for C.
So for C, if you look on this sigma here, sigma X, that's the sum of all the numbers. If you go back and look at what part C is, and actually I'll snip it in here. Part C wants the point estimate for the proportion of females. And if you look at the table again, you see that let's go back and look at it. You see that the employee 1, 2, 3, 4, 5, those are all, sorry, we don't need that. What is it's the proportional, sorry, it just wants the proportion. So you're just basically counting how many females are there out of the total. There are 5 women out of 8. So it's actually not related to this sum. Sorry about that. It's just 5 out of 8. And I don't know if it'll take that or if you want to put that in your calculator and do 5 divided by 8 like that. So 0.625.
To do 0.625.
Yeah, or I think it'll take 0.625.
Then you want me to submit it?
Yeah, go and submit. Let me know if there's any errors so we can look at it again.
Those are all right.
Great. Okay, so let's move on to 7.
Okay.
Okay, so they say an experimental diet to induce weight loss was followed for 1 week. They selected 12 students and they recorded their weight loss here. Part A is to determine a point estimate for the average amount of weight loss. So let's look at that, and then variance, and then standard deviation. Okay, so part A, you need the mean. Part B, you need the variance, which is S squared. Part C, you need the standard deviation. Okay, so all of these things you get from the calculator. Like you would not want to try and do this by hand ever. So we will be going back to the calculator. We're going to enter this information. So a good practice to do this, at least for first couple of problems here. So let me go back and share the calculator. We'll do that one more time here. So I'm just going to clear my screen. I'm going to go to stat edit. Let me know when you get to that stat edit. Now this is where I was mentioning, like, see how we already have data in L1.
Yeah.
You want to go up to L1 with your arrow and hit the clear button. And then you have to hit enter. Calculators are not like phones. They're not modern, but they do still do a lot. Let me know when you get kind of your screen there.
Yeah.
So we're just entering the data from that list there. So 1.9, 2.3, and so on here. You don't have to put 0.4, you can just put 0.4. It will not show the decimal places. It won't show like 0.0. Main thing
0.0, do I just do 0.0?
Or just 0?
Okay.
Yeah. All right, so let me know when you get all those calculated, or I'm sorry, all those in the calculator.
Okay, and then hit enter.
When you're all done, you're going to quit out. So hit second and then quit.
Okay.
And then to actually do the calculation, you go to stat and then go over to calc. Let me know when you get there.
Got it.
And hit enter. And then to get list one, because everything you just put is in what's called list one, you hit the second button and see that L1 there above the one, you hit enter on, get that, select that.
Okay.
And then this is the moment of truth. Hopefully we both put the data in wrong or incorrect. Is your mean 2.5?
Yes.
Great. So so there's a bunch of other things that this gives you. Sometimes it gives you exactly what you want. Sometimes it doesn't. So the part C is the standard deviation. That's this SX.
Okay.
And let me see what it wants you to round it to. It says 3 decimal places. So your SX, which is the standard deviation, is 1.472. I'm writing these down. I'm going to go back to the screen with that. Let me snip this in as well. All right, new share. Okay. So just if you look at the problem, part A is asking for the mean, X bar, that's the 2.5. Part C is asking for the standard deviation. And I know that there's some other questions it's asking. We'll talk about that in a moment. The part B, though, is asking for the variance. So variance is the square of the standard deviation. Okay, so you might think to just square this number. What would be better is to actually carry out from the original calculation here to go out a few more decimal places. So take that 1.471548 and square that, and then round it to 4 decimal places. Is that okay? I'm not sure if my description was clear enough or not. 48.
I accidentally.
2.165. Okay. This is for variance. So try those 3 answers for A, B, and C whenever you're caught up here, and we'll
Okay, and then for B, do I say yes or no, or?
let's come back to those because I'm pretty sure you can go out to the web and find those answers. Let's stick to the numerical ones just because I'm concerned we're not going to get through everything you want to.
It says
today.
B was incorrect. Let me see if I did it wrong.
Maybe not. So there's also the possibility that they wanted us to use the sigma, not the S, because I can't tell. Can't tell from this. So let me just double check this doing it another way. All right, so variance of the sample. Did you type in 2.165?
Yes.
And it did not like that?
No.
Did it take part C? Was part C correct?
Yes.
Oh, 4 decimal places. That's why. Sorry. Oh boy, there's always a little thing there. 2.1654. That's why I didn't like it.
Okay. It's good.
Is that all? Is that okay?
Yeah.
All right.
Well, I'm scared to check it again because I don't know how many attempts I get.
I see. Let me look here. You get 5 you get 3. So just so you know, it checks them independently. So you get 3
Okay.
attempts per part.
Oh, okay.
So what I don't recommend on the 5s is guessing between them. Let's just do the numerical ones, and if we have time, we'll come back. I'm telling you that you can go look these up, but
Okay.
they're all out there. The red means those numbers are different, so you won't find exactly yours.
Okay.
But for the ones that are the other way, you can do it. Okay.
So should I clear out now?
Up to you.
Okay. All right. What number is this one?
Sorry, 7, 8.
Okay.
8. Okay. Simple random sample of 100 observations taken from a large population. The sample mean and standard deviation were determined to be 1,234, that's X bar, and S is 190, okay? What is the standard error of the mean? So the standard error is the standard deviation divided by the square root of n. In this problem, your standard deviation is 190. Your sample size is 100.
Okay.
If you want to go ahead and calculate that for us.
Yep. 190. $19.
That's 19.
Sweet.
All right. Number 9 here. Let me know when you're ready for that. And you're welcome. If there's an error, let me know if you're checking those along the way.
I'm ready.
All right. A population has a standard deviation of 5. If a sample of size 25 is selected from this population, what is the probability that the sample mean will be within plus or minus 2 of the population mean? Okay. This is really an empirical rule problem. I don't know if you remember that from last time or maybe from class. There's like these rules that govern if you're within 1 standard deviation, it's about 68%. If you're within 2 standard deviations, it's about 95%. Have you seen that before?
I didn't go to class last week.
That's okay. I'm just asking if you remember seeing that or not. Like,
No,
don't.
I don't think so.
Okay, so this is, let me get a better picture then of this. This is really important because it's the kind of question they ask you on a test or quiz, and it's not difficult, but it's easy to mess up if you don't know the empirical rule.
Okay.
It's not really a rule. It's just an image here of this. All right, there we go. I like that one a lot. Nice, colorful image here. Okay. All right, so the empirical rule here, the total area under the curve is 100%.
Okay.
Okay, but within 1 standard deviation, 1 and 1, so -1 to +1 is 68%. That's what I was trying to explain there.
Okay.
Within 2 standard deviations, from -2 to +2, it's 95%.
Okay.
Within 3 standard deviations, it's 99.7%. So you'll see this on a study guide. You'll see this, leading up to your test. Now, in terms of like what is important to you, the answer is 95% because that's what the empirical rule says.
Okay.
It has nothing to do with whether the standard deviation is 5 or square root of 25.
Okay.
It's kind of related to what we just did, but just that's a good review of empirical rule.
Alrighty. Let me see. Yeah, that one's right.
Okay. All right, so I think we're gonna look at number 12 next. The next couple are just sort of Quizlet type problems you'll find out there. All right. Population has a mean of 300 and a standard deviation of 30. Okay, so X bar is 300. The standard deviation is 30. And the sample size is 144. Okay.
Mhm.
It wants to know the probability that X is between 295 and 305.
Mhm.
And there's a couple of ways to do this. One is to use the calculator, meaning like there's a way for you to just populate these numbers and get out the result there. Would you like us to use the calculator for that, or do you want us to calculate Z values? And then we also kind of have to use the calculator, but
Whatever you think.
okay. All right, so here we go. We're going to go back to the calculator here. Let me just make sure I know where it is first before as bars, second, and then I'll share my screen, normal, so yeah. Okay, so we're going to use something that's called, and I'm going to share my screen in a moment, normal CDF. Okay, and here's what normal CDF, and I think yours will show this. It requires you to give a lower, an upper, an X bar or a mu in this case, and a sigma. Okay. So your lower is going to be 295. That comes from this here. Your
Mhm.
upper is 305. Okay. Your mean is 300.
Yeah.
Okay. Now your sigma you might think is 30 because that is the standard deviation. Because the sample size is 144, you have to then convert this using the standard error formula. So the standard error formula is S divided by the square root of n, which is 30 divided by the square root of 144. That's what you're going to put in for sigma. Like you can actually type this in, it will do the calculation for you. So let's go to the calculator here. I'm going to share that. Any questions though, before I move to that?
No.
Okay. All right. So from your home screen here, you're going to hit second and then distribution, which is above vars.
Okay.
Second distribution. Okay, and you should see normal CDF. That's the second one, not PDF, CDF.
Got it.
Now, when you hit enter, yours likely will show that lower, upper, mu, and sigma. Mine does not.
Mine looks the same as yours.
Oh, wow. I'm sorry. You got a inferior calculator. Okay, so you're going to type in 295,
Okay.
comma's right above the 7, 305, comma. The mean is 300, comma. And then the last part is a standard deviation 30 divided by the square root of 144. And then the last close of parentheses here closes out the normal CDF. So let me know when you've got that entered, and then we'll hit enter. Hopefully we've got the same values there.
When I hit the parenthesis, it went underneath the square root.
Like, could you? What do you cut? I don't follow. That's why I'm stumbling here. Do you can send me a picture of your screen of your calculator? You could just retry entering it. You can also here. Let me hit enter.
Let's try and
You can also do this. You can also do 30 divided by the square root of 144 just to get that number, and then use that number in the calculation, which is 2.5. So you could like put 2.5 here instead of this. I think what you said is the 30 and then the fraction part went underneath and then there was a square root.
yeah, so I hit
That's
divide.
okay. Yeah, that's fine.
Then I hit second x2.
Mhm.
Second x2. Then do I do space?
No, you should be able to just enter that number.
So then hit the parenthesis, right?
Maybe yeah. Your 84's got a little more features where you can sort of typeset it the way you.
Okay, I got the same number as you.
Good. That's the most important thing.
I don't know why I was doing that.
All right. Let me.
0.5, what do I do?
What's that?
I just have the 0.9544 number.
That's good. The second part was just there to help.
Oh, okay.
Like with showing you that you can do the calculation of the part off to the side if you want. All right, I'm gonna snip this in, and you can look at that here. Let me go back to the other screen.
Yeah, that one's right.
Great. All right, so let's look at 13 next. All right, a simple random sample of 64 observations was taken from a large population. The sample mean and the standard deviation were determined to be 640 and 160 respectively. Okay, I want you to look at this one more time, and I want you to tell me what is X bar, what is S, and what is N, if you don't mind.
So, would S be 64?
64 is the number of observations. That's going to be your N.
Okay. And then for X, would it be 640? Oh, no.
Yes, X bar is the average. That's the sample mean. Mean and average are the same thing.
160 for
And
S.
160 S, yes. So the standard error, this is something you have to know, or it's going to be on a reference sheet. The standard error is the standard deviation divided by the square root of n.
Okay. So then what do I do here?
So do you have a value of what is the value of S in your?
Oh, 160. So
Okay.
160 divided by square root of 64.
Yes.
20.
Should be 20 there. All right.
Yep, that's right.
Great. All right, number 14.
Yeah.
Get this one next. All right, a population has a mean of 60 and a standard deviation of 18. A sample of 81 observations will be taken. All right, so just from that first sentence, okay, that first thing there, I want you to tell me X bar, S, and N, please. It's really important that you be able to identify these.
Yeah. So the mean is X, right?
Yes, the mean is X bar. What is the numerical value of X bar?
And then 81 is N.
81 is N for sure. Good.
Then S would be 65.
You're just looking at that first sentence, just that first sentence there.
Oh, okay.
Nothing
Oh, I
more
didn't
than
see
that.
the 18.
What is X bar? What is S from that first sentence?
So would X bar be 18 then?
Standard deviation
Or
is so mean or average,
divided by,
standard deviation, and then number of samples or observations. So X bar is 60 and S is 18. Okay. Now the second sentence tells us what we're actually asking to calculate. Find the probability that the sample mean will be larger than 65. So we're trying to find the probability that X is greater than 65.
okay.
Okay. Now this is another normal CDF problem. And if you recall, normal CDF, it needs a lower, it needs an upper,
Yeah.
it needs a mu, and it needs a sigma for your calculator. Now the problem with this one is it's 65 and bigger. So in terms of like, you know, think 60 is right in the middle. That's the average. And 65 is here. So we
Mhm.
need to find everything to the right of 65. So the lower is 65 because it's greater than. Whenever you have a greater than, that number is your lower. The question is, well, what is the upper? And this is where a lot of students struggle. If you don't know the upper, it's 10 to the 99.
Okay.
And if you don't know the lower, it's minus 10 to the 99.
Okay.
Okay. But since we know the lower, we use the 65. Since we don't know the upper, we're going to use 10 to the power of 99. The mu is your X bar. And I know this is confusing. Like, why is it X bar? Why is it mu? I mean, that's where, you know, probably don't have time to get through all that, but I'll show you how to do the calculations at least.
Okay.
And sigma is really S, but it's the standard error. It's the standard error. You have to take your S and divide by the square root of n. Your S is 18 divided by the square root of 81. And that's where you can either do it in the calculation, or you can go off to the side and do that calculation and then put the
Okay.
result in. Okay, so we are now ready to go to the we can now go to the calculator and do this. Any questions on that before we jump over to that?
Yeah, I'm on normal CDF right
Great,
now.
great. I like that.
Okay. So put 65, comma 110.
Okay. Let me know when you got all that.
Okay, I got the same. Yeah, I got the same number.
Okay. All right. So, doesn't seem that difficult. It's good. It's really good that you're trying to do this on your own, because you don't want the first time you do it to be on the test. You
Yeah.
want to know that you've
It's confusing with the calculator.
yeah,
I have trouble with the calculator.
I get it. It's not, it's not ideal. Okay, let's go to so I'm skipping 16. It's just asking for an average. I'm pretty sure you can do that. Let me go back to the other screen here. We'll do 17. It's a little more involved. All right, so for 17 here, it says a population of 1,000 students. So that's N. So what you want to do on a test quiz, you really want to label them as you see them. That's N. That's N. An average of average, that's X bar. The standard deviation of the expenditure is 4. Standard deviation is S. A simple random sample of 64 students is taken. Okay, so this is where maybe there's confusion. You're like, hey, Matthew, you just said N is 1,000. Well, it's saying like everyone that they could have sampled is 1,000. So actually the true N is the ones that they sampled, which is 64.
Okay.
All right, so always good to kind of label those values, extract them from the actual problem here, because there's a lot going on. All right, part A, what is the expected values of the sampling distribution of the sample mean? It's a really complicated way of asking for the X bar. That's it. There's nothing else that it's asking for. Okay, now the standard deviation of the sample mean is 4, but I believe they want you to, it's really asking for the standard error. And the standard error is S divided by the square root of N. Okay, so your S here is 4. Square root of 64 is 16. I'm sorry, is 8. Sorry. Yeah, it looks like 0.5. Go ahead and try that for me though, because it is written a little oddly. It's also asking you to round to 4 decimal places, which is weird. You don't need to, but
Yeah, it
if you
says
don't,
0.5 is wrong.
yeah, that's what I was wondering. So this presumes that you're not accounting for all the sample size. So go ahead and try just 4 in that position, please.
Okay. That's it. The answer is 0.4840.
That you only got one submission on that?
11.8 is right. I think I could do it again. Oh wait, no, why did it give me the answer then?
Yeah, that's really odd.
Let me just try and put the answer in then. See if that'll work. Yeah, now it gave me the answer, so I just typed it in and then checked it again, and it's right.
Wow, good. That worked out nicely. Let me just doing a quick search on this. Oh, I see. Okay. Yeah, this one is using, this is the power of having the internet available. I wouldn't have known to do this without looking. So there's this standard deviation formula that includes big N, which in our problem is 1,000. And little n in your problem is 64. So you can see it is the 4 over the square root of 64, but then you also have to multiply by this. So this would be a question to ask your teacher, is to say, like, when do I need to use this formula?
Mhm.
And I think you'll find that you don't need to use it, but that would be my concern, is like it not being clear when to use that or not. Okay, so we know that sigma is 0.484. We're going to need that in the next problem here. Part B. All right, what is the probability that these 64 students will spend a combined total of more than $803.69? This is asking for the probability that X is greater than $803.69 like that. So just like before, this is a normal CDF problem.
Uh-huh.
So you need your lower, you need your upper, you need your mu and your sigma. Now sigma is the one from the previous problem. That's the 0.4840. The lower, when you're doing a greater than that, that is your lower value, 803.69. Your upper, since you don't know it, is 10 to the 99. And your mean is the 11.8 times 64.
Mm-hmm.
Now, actually, we do need to change the sigma value. This is not the correct sigma value for this one. It changes because there are 64 people.
Okay.
So I want to just confirm the answer here. There's an adjustment formula for this, and just make sure. Why did it do that? Just a moment here. So they actually do it differently in this solution. They actually take the lower and they modify it. I guess you guys aren't doing that in your class. They take the lower and divide it by the number of students. That way you don't have to manipulate these other values.
Okay.
So that 803.69 divided by 64, that's what each student spends on average. So I believe that will work there. So you're going to go back to your calculator in normal CDF to calculate this. Let me do that here as well.
Type
803.
in 803.69 divided by 64.
Yep, and then a comma. So the calculator will do that calculation for you as you go. 11.8 is the third one, and then 0.484 is the last one there.
For 0.058.
7, yeah, 4 decimal places. Please try that, and I really hope that that works, so we don't have to.
Yeah, that's right.
Great. All right, so the next one is related. It's gonna be very similar to the previous calculation here, part C. All right, so we want the probability that X is between 790.67 and 818.81. All right, and then we're still going to use the calculator. We're still going to use normal CDF because we've got both the lower and the upper limit. Like we're in much better shape here. But the lower and the upper have to be divided by 64.
Okay.
because we want to know what it is per person. And then your mu is still the 11.8. Your sigma is still the 0.48484. All right, so I'm just entering this in the calculator.
0.1060.
Maybe I'm almost there. A little slower here on this side. All right, I got 0.1061. Is that different than yours? Snip that in here.
Let's see. Yeah, it's the same.
Okay. All right, good news is 18 is really similar, which means in good shape for that one.
Yeah, those are all right.
All right, here we go. On to 18. All right, SAT scores have an average of 1200, standard deviation of 200. So that's your X bar, that's your S, and N is 64, okay? For the first one, we want the probability for part A, probability that X is greater than 1,221. So this is a normal CDF. Your lower is 1,221, your upper is 10 to the 99, your mean is 1,200, and your standard deviation is 200 divided by the square root of 64.
Shoot, so be clear. Zero point two zero zero.
4 decimal places. I mean, you go ahead and yeah, probably I'm gonna let's you can I don't if it's gonna take me more time to calculate, it's probably worse, but go with that. For the next one here, the probability that X is less than 1, 2, 3, 3. So the only change here is that when it's less than, you're using minus 10 to the 99 as your lower, because you don't know how far less than to go. You go forever. 1233 is your upper. It's still 1200. It's still 200 divided by the square root of 64.
Oh, I didn't like whatever I put in. Shoot.
So with this one here, make sure it's the negative symbol, which is under the 3.
Oh, okay, that's what I did. All right.
All right, so for the third one here, it's between 1200 and 1215. You're going to use normal CDF yet again. Get the good flavor of this for this. This time though, they give you the lower and the upper, so you just put those in the lower and the upper. Mean still the same, standard deviation still the same, and so on. The last one is the probability that X is greater than 1200. So again, it's yet another normal CDF.
Okay.
1200 to 10 to the 99. 1200 comma 200 divided by square root of 64. Now this one's kind of interesting because the mean is 1200 and they want to know that it's greater than 1200. 1200 is the dividing point in the middle there, so it's actually unknown value. It's 50% or 0.5.
Okay, that's the answer for that one.
That's the answer.
All right.
So for number 20, this is really similar to what you just did. I recommend doing 20 next. We're pretty much out of time. 19 is more complicated, but it's probably available online if you want to check that out. And then the rest are not, either they're kind of Quizlety, or you've got enough guesses where well, I take that back. you can probably do a few things to figure them out, but that will do it for us today. That will take us to the end of our lesson.